Hi, good evening everyone. This is Shefali Singla, and in this session we will be learning few more concepts of computer organization and architecture through questions. So आज वाले सेशन में हम लोग थोड़ा सा नेक्स्ट टॉपिक को कवर करने करेंगे दैट इज पाइपलाइनिंग. So pipelining will talk about address lines, data lines and so on. So I hope that audio and video is fine. So let's start with the first question for the day. First of all, this is one of the very simple question. It is asking that an address in the main memory is called. Main memory में address को क्या बोलते हैं? Is it option A, virtual address, memory address, logical address, or physical address? So address of the main memory is nothing but this is known as the physical address. Basic term है क्योंकि जो CPU generated address होता है that is known as the virtual address. And if you know the virtual address or the logical address bits, that's going to tell you that what is the logical address space, what is the physical address space. Physical address space can be determined on the basis of the physical address bits. So basically, a main memory is nothing but that is the physical and the main memory of the system. So that is why an address in the main memory is called physical address. All right, next one. Here you are supposed to return the size of the address bus of the processor. Here it is saying that a processor can support maximum memory of 4 GB. यानी कि जो processor है वो total memory कितनी support करे? Memory supported is 4 GB. We know that 4 is nothing but that is 2 raised to power 2. G is 2 raised to power 30 bytes. सो टोटल मेमोरी आपके पास 4 GB की है. अगर हम इसको डायग्रामेटिकली देखते हैं, दिस इज 4 GB ऑफ मेमोरी, 4 GB of memory, and this memory is word addressable and you are given with the size of the word. So this means that if 4 GB of memory is there, so can we count the number of words? Words is nothing but जब आप memory को divide करते हो cells में, each cell is representing one byte or the word. It depends on whether the memory is byte addressable or word addressable. Memory byte addressable or word addressable कुछ भी हो सकती है. The only thing is in the byte addressable memory size is fixed, but word addressable में processor के ऊपर size vary करते हैं. Depending on the processor, the size is going to vary. So here total memory is 4 GB. Total 4 GB थी. इस 4 GB को आपने divide कर दिया किसमें? Into the partitions where the size of each partition is 2 bytes. So this means that it will return the number of cells, and these cells are nothing but this is representing the number of words. एक छोटा सा एग्जांपल लेते हैं. फॉर एग्जांपल वी हैव 8 बाइट्स ऑफ मेमोरी. आपके पास 8 बाइट्स की मेमोरी है. आई वांट टू डिवाइड दिस मेमोरी इनटू the cells, and size of each cell is nothing but the word. Size of each word is size of word is, let's say, 2 bytes. So how many cells will be created? कितने cell होंगे? Total memory is 8 bytes. So first में आपके पास 2 bytes की memory आई. Then again next 2 bytes, next 2 bytes. So ultimately there are 4 cells or 4 words in the memory. Now in order to represent each word, since there are 4 combinations, so in order to represent each combination, 2 bits are required. इसी चीज को हमें जो ओवरऑल आपके पास 4 GB की मेमोरी दी हुई है, वी हैव टू अप्लाई ऑन इट. So we can say that number of words is nothing but we can say that number of words कितने हैं आपके पास? Number of words are 4. How are we getting these 4? That is nothing but the total memory divided by size of each word. Total memory divided by size of each word. So now Here you are given with the total memory size. So we can say that number of words. Can you tell me that how many bits will be used? यहाँ पे आपके पास अगर 2 bits आ रही हैं, that means address line, कितनी address lines होंगी? It will be 2. So 1 and 1, so 2 bits, क्योंकि आपके पास जो address बन रहा है वो 2 bits के साथ बन रहा है. Here we are given with 4 GB of memory, so we can say that number of words will be equal to 2 raised to power 32 bytes. I'm getting from here, this is 2 raised to power 32 bytes divided by size of each word. Size of each word is given as 2 bytes. So this comes out to be divided by 2 bytes. Units का हमेशा ध्यान रखना है. So this comes out to be 2 raised to power 31. If there are 2 raised to power 31, then number of bits required will be, obviously for that we need to take the log. So number of bits will be 2 raised to power log 2 raised to power 31. So that comes out to be 31 bits. Now, at least 28 bits with at least 28 bits or with 28 bits, you cannot represent 2 raised to power 31 combinations. With 2 bytes, it's 2 bytes means 16 bits. With 16 bits, you cannot represent these combinations. So it is at least 31 bits. Answer is 31 bits. So the correct answer for this question is it's option 3. Is this clear? कुछ भी नहीं करना था. You just have to calculate that how many words will be there, and then simply in order to represent each word, how much memory is required. Let's move on to the next question. Just go through it. It is based on the hardwired control unit. So we have talked about hardwired and vertical control unit. So just tell me that which one of the following statement is true. Control memory is a part of hardwired control unit. Control memory is not a part of hardwired control unit. Program control instructions are used to alter the sequential flow of the program. It's about the control instructions. क्या control instructions जो आपके पास sequential flow होता है program का, क्या उसको change करता है? Definitely. That means आपके पास जो program counter में address होता है, that is the address of the next instruction. So that will get changed जब भी आपकी instruction decode होती है, and if that instruction is decoded as the control instruction, then it may change the flow of the sequential program. So this statement is true. The register indirect addressing mode for accessing memory operand is similar to displacement addressing mode. Obviously, this is not the same. So this statement is false. CPU utilization is not affected by the introduction of interrupts. This statement is also ये बोल रहा है कि CPU को कोई फर्क नहीं पड़ता. Definitely CPU को फर्क पड़ता है, because जैसे ही आपके पास interrupt आती है, interrupt served routine work करता है, तो उस टाइम पे what CPU is doing? CPU will get idle. CPU की जो execution चल रही थी, अगर कोई interrupt आ गई, then that interrupt will be handled. So during the interrupt handling, CPU is not performing any task, so definitely CPU utilization कम होती है. But here it is saying that it is not affected, so this statement is also false. So the correct answer for this question is, which of the following statement is true? It is statement B. So option 2 is the correct answer. Next one, how many address lines and data lines are required to provide a memory of capacity 16K into 16? 16K into 16 का क्या मतलब है? We have 16K cells, or you can say that 16K words are there, where the size of each word is 16. That means in one word, 16 bits can be stored. Very good evening, Priyanka. So if 16K words are there, 16K cells are there, that will tell you this number of words will tell you the address lines. और हर एक word के अंदर कितना data है? It is containing 16 bits. So if I show it diagrammatically, we have the cells कितने cells हैं? These are 16K. So in order to represent 16K, how many bits are required? That is what will be returned to the address lines, and data lines is here the size of one word is 16 bits. That means when you are transmitting one word of data, जब आप एक word को transmit कर रहे हो, that means you are sending 16 bits. So what will be the number of address lines or the data lines? I have given enough hints. इसके बाद तो फिर मैं आंसर ही बता सकती हूँ. This will tell you size of word will tell you the data lines. Size of word will tell you the data lines. Come on. 16K is nothing but 14 and 16. Very good, Arun. So, जिन लोगों का I'm so sorry. Oops. I guess it's gone. Anyways, so I have told you that 16K into 16, this is the size of the word. So, size of the word will determine the data bits transferred. जब एक word आएगा तो data bits कितनी transfer हुई? Data bits transferred. So that means this will give you the data lines. So data lines कितनी आई आपके पास? 16. So on the basis of this, we can eliminate option 1. 16K is representing the number of words. Number of words. एक word को represent करने के लिए कितनी bits चाहिए? That tells you the address line. So simply we can say that log base 2 number of words will give you the address lines. Here 16K can be written as 2 raised to power 4 into 2 raised to power 10, that is 2 raised to power 14. That means 14 bits are required to represent the address lines. This is representing the address line. So the correct answer is 14 and 16, that is option 3. Simple. Next one. Which of the following statements with respect to K segment pipelining are true? Now this is the question related to pipelining. K segment है यानी कि K steps है, K stages हैं, K segment pipelining are true. What can be the maximum speed up that a pipeline can provide? Obviously that is K, that is equal to number of segments. Yes, so this statement is true. It is impossible to achieve maximum speed up K in K segment pipeline. Definitely this is theoretically possible, but practically you cannot implement this. So this statement is also true. Third statement is saying that all the segments in the pipeline take some time in computation. हर सेगमेंट में पाइपलाइन के हर सेगमेंट में सबको सेम टाइम लगता है. वी हैव केम अक्रॉस सम इंस्ट्रक्शंस जहाँ पे डिफरेंट सेट ऑफ इंस्ट्रक्शंस आर टेकिंग डिफरेंट segments, a different number of clocks for computation. So that means सारे segments में pipeline के सारे segments में same computation time नहीं लगता. So this statement is false. Choose the correct answer from the given options or given options मतलब आपको ये बताने कौन कौन सी statements true थी. So this is statement A and B which was true. So correct option for this question is it's option 1. Correct? Next one. Shall I move to next question? Here you are supposed to do some calculation. So you have to calculate the speed up factor. This question is from the concept pipelining and you are supposed to calculate the speed up factor. A non-pipeline system takes 50 nanoseconds. एक कोई non-pipeline system है जिसमें 50 nanoseconds चाहिए. So can I write this as Tn? I'm calling this as Tn is for non-pipeline, time for non-pipeline, for non-pipeline. That's why I'm writing this as Tn. N means non-pipeline. So it is taking 50 nanoseconds. The same task can be processed in 6-segment pipeline. That means number of segments are given to you. I'm representing number of segments with K. There are 6 segments with a clock cycle of 10 nanoseconds. So यानी कि आपके पास पाइपलाइन में टाइम कितना जा रहा है 10 nanoseconds. Determine approximately the speed up ratio of the pipeline for 500 tasks. यानी कि आपको number of tasks, you are given with the number of tasks, that is 500. So every single thing is given to you. 500 tasks are there. What we have to calculate? Total how much time is required. अगर non pipeline की बात करते हैं, non pipeline में कितना time लगेगा? एक instruction के लिए this is taking, एक task के लिए it is taking 50 nanoseconds and we are given with 500 tasks. So we can calculate the total time required in the non-pipeline processor, and speed up is nothing but the time required in the non-pipeline processor divided by time required for non-pipeline processor, that is for number of tasks, n task hai, and for each task it is taking 50 nanoseconds. Whereas in pipeline, कितनी clocks चाहिए? हर एक clock cycle के लिए 10 nanoseconds चाहिए. How many clocks are required? We have derived the formula for the first output. First task को सारी stages से होके जाना पड़ेगा. That means k clock cycles के बाद पहली output मिलेगी. If the pipelining is implemented successfully, then in every consecutive clock you will be getting the output. तो फर्स्ट इंस्ट्रक्शन के लिए तो के क्लॉक साइकिल्स लगी, उसके बाद रिमेनिंग इंस्ट्रक्शंस आर n minus 1. फॉर रिमेनिंग n minus 1 इंस्ट्रक्शंस इट इज टेकिंग 1 clock. TP. Everything is given to you. You just need to substitute the value. Quickly substitute the value and perform the calculation. So 500 tasks are there and it requires 50 nanoseconds. Divided by k, number of segments are 6, plus number of instructions are 500 minus 1 into size, that is into time required for each clock cycle, that is nanoseconds. So this is in the nanoseconds, this is in the nanoseconds. Anyhow, this will get cancelled out. So ultimately this comes out to be 25000 500 and 5 into 10 is 5050. This comes out to be 4.95. So speed up is 4.95. कुछ भी नहीं करना था. If you are comfortable that how to find out the time for the non-pipeline, then easily आप calculate कर सकते थे क्योंकि सारी की सारी values formula की directly equation में given थी. Okay. One more question. Here we are supposed to calculate the speed up of the pipeline for 100 tasks. So number of tasks are given to you. Non-pipeline में कितना time लग रहा है? 4 segment pipeline है. Clock cycle is given to you. So this question is exactly similar to what we have discussed now. So just calculate the values. ये important type का question है. So basically in this question you are calculating the time कि बिना pipeline के कितना time चाहिए और pipeline के साथ कितना time चाहिए, and speed up के लिए obviously will be dividing both and you'll get the answer. So do you want to try? A non-pipeline processor is taking 30 nanoseconds. Number of segments are 4. Clock cycle time in the pipeline, this is for non-pipeline, it is 10 nanoseconds and number of tasks are given as 100. Same concept, S is equal to N into Tn. This is for non-pipeline processor, and for pipeline processor it is K plus First instruction will be taking k clock cycles, n minus 1 TP. Substitute the values, everything is given directly like the previous question. Pipeline. What is the correct answer? दोनों nanoseconds में दिए हुए, so you can cancel that out. This is cancelled out, so it comes out to be 300 divided by 103. That is nothing but 2.91. So correct answer for this question is it's option 4, that is 2.91. Simple. Next one. The period of a signal is 100 milliseconds. Then what will be its frequency? We know that frequency is nothing but that is inversely proportional to the time. Frequency is 1 upon t, that is time, inversely proportional to time. Time is given as 100 milliseconds. T is given as, T is nothing but that's the period, that is given as 100 milliseconds. So you just need to substitute the value here. Milliseconds. So this will be, expand this, milli is 10 raised to power minus 3 second. और हमें ये मालूम है कि जो frequency है, unit of frequency is hertz. So whatever answer you'll be getting, that is in hertz. So it is 100 into 10 raised to power minus 3 hertz. But if you look at the options, this is given as 100 raised to power 3. 100 raised to power 3 means आपके पास 6 zeros आएंगे, that too in the numerator. Not possible. क्योंकि सब कुछ हमारे पास डिनोमिनेटर में है, so I can write this as 1 upon 100 into 10 raised to power 3, क्योंकि हमें ये मालूम है कि 1 kilo is equal to 10 raised to power 3 hertz. तो आंसर आपके सामने, so this is 10 raised to power minus 2. 100 can be written as 10 raised to power minus 2 into or 10 raised to power minus 2 kilohertz. That is nothing but that is option 2. Is this clear? So आज वाले सेशन में इतने ही. So we have solved like 6 to 7 questions. I hope clear हुए होंगे. So we have taken more questions on pipelining. कल वाले सेशन में I'll be focusing on the pipelining and the cache memory organization. Okay, so we will be covering the concepts through the questions of pipelining and cache memory organization. So revise your concepts and join the session at 6:30 p.m. to go through the concepts. Okay, anyone having any doubt, any query? So those who are new on this platform, guys, you can subscribe the channel and hit the bell icon to get the notifications of all the videos. And apart from that, if you want to cover the whole syllabus in detail in the live classes, then you can join our super coaching batch. So super coaching batch में paper 1 और paper 2 के सारे units live session में जा रहे हैं. Paper 1 की classes होती हैं 12:30 बजे. We are having the paper 1 classes at 12:30 in the noon, Monday to Saturday. We are aiming to finish our syllabus by the end of April or max to max फर्स्ट वीक ऑफ मई, ताकि उसके बाद हमारे पास सिर्फ और सिर्फ क्वेश्चन से रिलेटेड सीरीज हो। और अभी पैरेलली आपको सुपर कोचिंग में टेस्ट सीरीज भी मिल रहे हैं, सो वॉट एवर सब्जेक्ट्स वी हैव फिनिश्ड, you can go through the test series in order to practice the questions. पेपर 2 की दो क्लासेस होती हैं पर डे, one in the morning and other one in the evening. Morning and evening. Morning में we are having the session at 7:30 a.m. 7:30 a.m. to 9:30 a.m. 2 hours का session होता है. And even in the evening also we are having 2 hour session from 8 p.m. to 10 p.m. No weekends are off, because अगर weekends off रखेंगे obviously will be stretching the syllabus till the end of May or the first week of June, तो उसका कोई फायदा नहीं है, क्योंकि जब तक आप प्रैक्टिस नहीं करोगे, रिवीजन नहीं करोगे, इट्स ऑफ नो यूज. सो प्रैक्टिस इज रिक्वायर्ड, तो उसके लिए हमें सिलेबस खत्म टाइमली करना पड़ेगा. So that is why no weekends are off, but some off is required. So that is why for the mornings we have Thursday morning off, and for evenings we are having Monday and Tuesday off, but no weekends off. No off on weekends. अगर आपको पूरा का पूरा schedule देखना है, how the things are going on, what and you want to follow the demo session, पूरा क्या क्या included है super coaching में, so for that the link of the super coaching is given in the description box. Just follow that link, explore the stuff, get to know that what all things are there, and then accordingly you can proceed. And if you are targeting on cracking the exam UGC NET in the first attempt in this June itself, then it's good to join the super coaching. And currently the discount is going on. For that, you just need to use the coupon code, that is Shefali S. So up to 90% का discount चल रहा है. So just see what is the actual price, and after applying the discount, how much discount you are getting. Okay, so this is the code that you can use. If you guys have any doubts or queries, you can ask. Otherwise, अगर लाइव नहीं है उस टाइम पे आप टेलीग्राम ग्रुप में अपनी क्वेरी पोस्ट कर सकते हो. टेलीग्राम ग्रुप का लिंक भी डिस्क्रिप्शन बॉक्स में गिवन है. Okay, so this is all about this session. I'll see you in the next session. Till then, take care. Bye bye. Thank you for joining the session.